In section 9.2, we're going to be talking about a couple different types of errors that can be made when we're calculating our confidence intervals and doing our hypothesis testing. And we call those type 1 errors and type 2 errors. So the 4 different things that can happen when we do a hypothesis test, there's 4 different things that can happen. Since there are 2 different outcomes that could happen for each type of hypothesis, we get 4 different scenarios. So the first thing that could happen is we might choose and we might come up with the conclusion that we should reject the null hypothesis when the alternative hypothesis is true. Okay, the alternative hypothesis is true, and we rejected the null hypothesis, and so that's correct. That decision would be correct. That would be a good outcome of something that could happen there. So that's one option. We might reject the null hypothesis when the alternate hypothesis is true, and that would be correct. Another thing that could happen, a second possibility, is we might fail to reject the null hypothesis when the null hypothesis is true. So again, that would be a correct choice. If the null hypothesis is true, we do not want to reject it. As opposed in number 1, if the alternative hypothesis is true, then we do want to reject the null hypothesis. So those are the 2 correct choices, or 2 of the correct choices that we could make in a situation. The third one is not quite so good. So the third one says, we might choose to reject the null hypothesis when the null hypothesis is actually true. And obviously that decision would be incorrect. If the null hypothesis is true, we do not want to reject it. So this is what we call a type 1 error. In other words, if you're thinking about kind of confidence interval thoughts, if this is your confidence interval and you're thinking you are 99% sure that you are in that range, and we believe we're out here, that's where we get this type 1 sort of error, type 1 error, and that means we thought we were out here in a range where the null hypothesis should be rejected, but it should not be rejected. And so that is a type 1 error where the null hypothesis is actually true, but we reject it. The fourth possible thing that could happen is we might fail to reject the null hypothesis when the alternative hypothesis is true. Well, again, that would be incorrect. If the alternative hypothesis is true, we want to reject the null hypothesis. This decision, again, is incorrect, and we call this a type 2 error. So this would be a situation where we believe the outcome landed in here, and so we failed to reject the null hypothesis, but actually it should have been out in this area where we should have rejected the null hypothesis. So we're going to be looking at these sorts of things and identifying these types of errors in this section. It is important to remember that when we mention above that H1 is true or that H sub 0 is true, we mean that there is enough evidence to support the claim. And so that's what we're going to be talking about. Not necessarily that it has to be true, but based on our evidence, based on our data, there is enough evidence to support a certain claim. Example 9.3, it is believed that 11% of all Americans are left-handed. A college needs to know how many left-handed desks to place in the big lecture halls being constructed on its campus. In a random sample of 140 students from that college, whether or not a student was left-handed was recorded for each student. The college wants to know if the data provided enough evidence to show that the students at this college have a lower percentage of left-handers than the general American population. State the random variable, the population parameter, and the hypotheses. State the type 1 and type 2 errors in the context of this problem. So now that I have a little bit more space to work with, let's go ahead and do this. State the random variable. Well, the random variable we'll call X, and that is the left-handed students. Okay, that would be our random variable. That's what we're looking for. The population parameter that we are dealing with is proportion. And in this particular case, our proportion is, we are told that 0.11 is the proportion of people in the United States, Americans in the United States who are left-handed. Our hypothesis. So our hypothesis would be that P, okay, let's start with the null hypothesis, would be that there is no change. P equals 0.11. That is what we believe to be true on our college campus, that the campus population proportion will be 0.11, just like the American population proportion. Then the alternative hypothesis is we are testing, where did it say this? We are testing to see if there's a lower percentage of population in our college that is left-handed. So we would say P is less than 0.11. And that makes this a left-tailed test because that's where our alternative hypothesis is going. Now, a type 1 error would be that we reject the null hypothesis when it's actually true. So in this situation, our type 1 error would be that we would find, how do I want to write this? So we would reject the population equaling 0.11 when it actually does equal 0.11. Okay, our type 2 error in this case, if we were going to have a type 2 error, is where we fail to reject P equals 0.11 when P does not equal, well, and actually we should say specifically, P is less than 0.11 because that is what our alternative hypothesis is. So we wouldn't reject that, or we wouldn't be required to reject that unless it was actually less than 0.11. So that is our random variable, first part. Our parameter that we're talking about was P. Then we have our two hypotheses here, and our type 1 and type 2 errors based on this scenario. Now we want to talk about the probability of making a type 1 or a type 2 error. And I see that I have a typo in my thing that I hadn't noticed before. So we'll try to get that fixed. There's only 2 R's in the word, well, 3, not 4 R's in the word error. So the probability of making a type 1 error is labeled alpha. And if you remember from our confidence intervals, alpha is the stuff outside of our confidence intervals. So alpha is going to be equal to the probability of making a type 1 error, which means that we would reject the null hypothesis when the null hypothesis should not be rejected, according to our data. The way we say it here a little bit shorter is that it's true, but really it's what it means is we reject the null hypothesis when we should not reject the null hypothesis. Then the probability of making a type 2 error we label as beta. And beta is the probability of making that type 2 error. And this is the probability of not rejecting the null hypothesis when it should be rejected, or when the data says that it should be rejected. In other words, we would believe that the alternative hypothesis is true. So the probability of making a type 1 error, alpha, is chosen by the researcher before the sample data is collected. They have to decide that at the beginning because they want to know how certain they are and all those sorts of things. The level of significance, alpha, is the probability of making a type 1 error. And as the probability of a type 1 error increases, so in other words, as you let alpha get bigger, then the probability of a type 2 error decreases, and vice versa. So let me draw a picture of this. Again, if alpha is our area, we can kind of split this up into 2 areas. We have the fail to reject area, and then on the outsides, usually we would call this the reject area, rejection area. Okay, so if you make your probability of making a type 1 error very small, that means your outside areas are very small, and that means you would hopefully not reject the null hypothesis when it's true. So you make those outside areas very small so you don't reject it if the null hypothesis is true. Then, on the other hand, if we change this around and we make the rejection area larger, so alpha gets much larger, that means our chances of making that type 1 error are larger, but it also makes our chances of making a type 2 error much smaller because we would be less likely to fail to reject the null hypothesis when it really should be rejected. And so that's the play between those two, the alpha and beta. As alpha gets larger, beta will get smaller. As beta gets larger, then alpha will be smaller. So that's the end of section 9.2. And again, just to review, our type 1 error is where we reject the null hypothesis when it should not be rejected. And then our type 2 error is when we fail to reject the null hypothesis when it should be rejected. So those are our two types, and I know your 4 graded problems there. Ask some questions about that. Again, if you get stuck on those, please make sure to contact me.